This is Laura Sullivan-Russett shooting the video for Programming Assignment 5, Part 2 for myself and my partner James Tomasko. As with my first video, I am going to run it and then discuss how we implemented. So as you can see, it is a lot of output, but at the very beginning, we've got H1 and H2 each sending messages. And so they each are connected to router A, which then encapsulates these packages and sends them on. And you will see here that router B processes all of the frames that come from H1, and router C processes all of the frames which come from H2. And so if you see here, there's link from router A to router C, and we're getting the H2 message, and then router B is forwarding all H1 messages. Router D at the end decapsulates all of the messages and sends them to H3. And as we get down here, you see H3 receives a message from H2, and H3 receives a message from H1. So the way that we implemented is we extended the simulation.py file to include a third host, and then we created 2 additional routers, router C and router D. And we determined the path that we wanted the messages to take and used our forwarding tables to help us make sure that the traffic from host 1 only went through router B and the traffic from host 2 only went through router C. And so in network, it really is very similar to our previous code where if it is an MPLS packet, then we will create an MPLS frame out of it. And that if the network packet is going to or from a router to another router, then it will get encapsulated. If it is already been encapsulated, it will be forwarded. And then if it needs to be forwarded on, then we send it as a link frame with MPLS. If it needs to be decapsulated, same as before, we get the network packet from the data of the MPLS frame and then send it on as a network link frame. And we use just this little bit of code here to determine which interface it is coming in on for router A, and that will determine which out interface it's going to send that packet on through. And that is it for that part.